Hey there. We're going to work with sets today, and we're going to focus on two goals. The first goal is to write sets and identify subsets. And the second one would be to find the complement of a set. So we're going to work with sets, um, writing them different ways, and then we're going to find complements of sets. So two parts here. Let's start off with just some general things about sets. Let's read through this essential understanding before we get into things. It says, sets are the basis of mathematical language. You can write sets in different ways and form smaller sets of elements from a larger set. You can also describe the elements that are not in a given set. So common sets that up to this point that you may have done is all like the real numbers, the set of real numbers, and there's subsets to that that would be like rational, irrational, natural numbers, whole numbers, and integers. Okay, we're just going to talk about sets in general now and how they're written. So the three forms that we have for writing, well, the two forms mainly, really, for writing sets are roster form and set builder notation. Roster form looks like this. It's using these fancy brackets and it's just listing everything. So it just lists all the elements within the set using braces, or the brackets. You can write them different ways. Like you don't have to write 2, 4, 6, 8. You could just write multiples of 2 starting with 2. But that gets into more of the set builder notation then, which is another way to write sets. It more describes it. So roster form lists it like a roster. Set builder notation describes it. So it's still using the fancy brackets here. So here's an example, fancy brackets. And what's part of set builder notation is the variable that we're using to represent the numbers, and then a description of the numbers. So x would be any multiple of 2. And that's it. That's how you list it. So separated by this line here. So those are the two main ways to write sets, and we're gonna practice that a little bit. The third thing I want to note though is what the empty set would be. Some of you have seen this symbol before, this 0 with a line through it. It means the empty set or the null set. It means null. And it just means nothing. There's nothing in there. It's the empty set because there's nothing to that set. All right. So let's go now. Let's start using these forms a little bit. Problem 1 says, how do you write T is the set of natural numbers that are less than 6 in roster form and then in set builder notation. So here's how it's done for you already. Roster form, again, we just list it. Remember, roster form, think of a list of things. It's a set of natural numbers that are less than 6. So that all that would be is 1, 2, 3, 4, 5. And that's why roster form works for this. All right. If this set is written set builder notation, we're going to use the variable. We're going to say x. Then we're going to describe it. We're just going to say x is a natural number. And you can describe it a different way. X is less than 6. So that's the description. And that is set builder notation. So those are the two ways to write sets. Now the got it says n is the set of even natural numbers that are less than or equal to 12. How do you write n in roster form and in set builder notation? Well, why don't you try that on your own? Write it in each of roster form and set builder notation. I'm going to do the same thing. So if you want to pause it, because I'm going to show you how to do it. So roster form, we're going to say n is the set, n is equal to fancy brackets. So I'm just going to list them. So even natural numbers less than or equal to 12. So 0 is not a natural number, so we're going to have to start with 2, 4, 6, 8, 10, and it could be equal to 12, so 12. And that is roster form. Set builder notation. Set builder notation, the nice thing about set builder notation is it'll work for very large sets. Roster form, you're not going to want to write tons and tons of numbers if it's huge sets. So set builder notation is nice for that. We're going to use the fancy brackets again. Let's use x. And it's, let's say, natural numbers, even natural numbers. I'm going to abbreviate here. Numbers, comma, we're also saying that x has to be less than or equal to 12. There's my fancy brackets. So that's how I would write it in set builder notation. And it's read x such that is an even number, even natural number, and x is less than or equal to 12. All right. Now you can write inequalities in set builder in these notations as well in set builder notation. So I just want to show you that it's a common way to use set builder notation is with inequalities. And that's what this whole chapter is about. So in set builder notation, how do you write the solutions to this? So we first have to solve it. And that's actually done for you here. So if you take that, you subtract 7 from both sides, and then you divide both sides by -5. Remember, when you divide by -5, the whole sign switches the way it's opening to. So you end up with x is greater than or equal to -2. So the way that you'd write that in set builder notation is that the set would be x such that x is greater than or equal to 2. That's all we're listing. So that would be b. It's just greater than or equal. Ooh, -2. I meant to write -2. All right, and that's using set builder notation with inequalities. Why don't you try this one on your own then? Number 2, in set builder notation, how do you write the solutions to 9 minus 4n is greater than 21? So you can pause it right now, and then I'm going to go through it. All right, so I'm going to change this to plus and -4n right away, and then I'm going to subtract 9 from both sides. So I have -4n is greater than 12. Divide both sides by -4 to undo that, or to isolate that variable. You're left with n. Switch the sign now when you divide by a negative is less than -3. So in set builder notation, we're going to simply say fancy brackets n such that n is less than -3. So we're using the variable n, and that's what it has to fall into. All right. Now the second part of this lesson, we'll get. I guess we'll talk about subsets real quick. Subsets are smaller sets that make up a larger set or an actual set. Okay? So when I ask you for subsets of them, it's what could be making up it. So if you think of the subsets of the real numbers, what would be making up all the real numbers? It would be all the rational and irrational numbers. But what are the subsets of this set right here? So this is the larger set, 3, 4, 5. And what could be a subset for that? Well, they're all actually listed here. You could do 3 as a subset of it, 4 as a subset of it, 5 as a subset of it, all by itself. You could take nothing out of it and say nothing would be part of it. You could take smaller sets like 3 and 4, 3 and 5, or 4 and 5. And then you could take the whole set because it's, I guess, the set itself is considered a subset of itself. Which is kind of weird, but as long as it makes up that larger set. So these are all the sets that make up, they're not listed here, but these are all the sets that make up, the subsets that make up that larger set. Interesting. So we're going to pass this right now. I want to just finally touch on what complements of a set are. And when you're talking about complements in math, we're not talking about, like, you look great today, or I really like your hair today. Not those kind of compliments. Compliments in math, you think of something that, like the complementary angles. They add up to 90 degrees. So if you complement something, it's two things that go together. So when we're working with sets, I'm reading right here on the top. You call the larger set you're using the universal set. So like before when we were talking about the 3, 4, 5, that would be the universal set. The complement of a set is the set of all elements in the universal set that are not in the set. you denote the complement of A by using this prime symbol, A prime. So let me show you how this works. And there's these symbols used for the complement, but it says in the Venn diagram below, U represents the universal set. I notice that A union U, oh sorry, and not union, A is a subset of U. That symbol means subset. So A is a subset of U, and A prime, or the complement of A, is also a subset of U. So that's what that symbol means. Um, if you didn't catch that before, this symbol means subset. Right, don't get that mixed up with the less than or equal to symbol. This one is rounded, like a sideways U. All right, so we have the universal set is this whole thing, and set A is a subset of it. It's inside of it. If you look at the whole thing here, U is the whole thing. A is the subset of it, and A prime is anything else in this whole universal set that's not part of A. So they complement each other. They go next to each other. They make up the whole universal set. And that's what complements of sets are. So here's an example. Universal set U is going to be the months of the year. And set A is every month with exactly 31 days. So 31 days, so I'm going to say set A is going to be January, March, May, hold on, July and August, October, and December. So if you didn't know that, now you know. Those are the months that have exactly 31 days in them. And now I'm asking, what is the complement of set A? So that would be A prime. It would be everything else in the universal set that's not part of set A. So the universal set is all the months, so I'm just going to pick out all the other months. So February, April, June, September, November. So those are the 5 that are not part of the set A. So they're the complement of it. They're the other ones that make up the whole universal set. And that's what complements of sets are. So let's take you back to the goals for today. To write sets and identify subsets, and then to find complements of a set. Hopefully you're able to do that at least somewhat now. Make sure you practice it and you ask any questions of your teacher that you have. Thank you. Have a great rest of your day.